I am Dr. Anantaya MB, Professor of Civil Engineering Department, SVIT Bangalore. Today we will see the continuation of the module 3rd, bending moment and shear forces. In that, types of loads. Types of loads. Types of loads. The following are the some of the type of loads. In that, first one is point load. Point load. Point load. What is point load? The point load is one which considered to act at a point as shown in the figure. I will write the figure. The point load is also called as concentrated load. First I will draw the one diagram. This is the beam. One end support is hinge support, another end support is roller support. Here one load I am applying with knife edge. This is called knife edge or arrowhead. The load will be represented by W. This W load is called point load. The point load is one. The point load is one which is considered to be act at a point as shown in the figure above. As shown in the figure, this point we will call it as B, shown in the figure above. Now here this W is called as point load. W is called as here W is the point load. It is having with a arrowhead or a knife edge. The second type of the load is uniformly distributed load. The second one is uniformly distributed load. It is called as UDL, uniformly distributed load. A uniformly distributed load is that load whose magnitude remains uniform throughout the length. For example, I am writing a beam here. This support is hinge support. Here one small circle. This end is roller support. Two rollers are there. Then the representation of the load like this. See here, this is represented by W per meter length. For example, the span is L meter. Here, the intensity of the load for each meter length remains constant. What is the load for 1 meter length? Same load is there for next meter length. Same load is for next meter. That means for each meter length, the intensity of the load is same. Therefore, a uniformly distributed load is that load whose magnitude remains uniform throughout the length. That means for each meter length the intensity remains same. In this figure, the intensity for each meter length is W, that is W per meter. Now let us see another type of the loading, third type. It is uniformly varying load. It is uniformly varying load. Uniformly varying. Uniformly where it is represented by UVL. It is UDL. This is UVL, uniformly varying load. It is the load whose magnitude varies along the loading length with a constant rate. It is called as uniformly varying load. For example, I am writing a figure here. This is the beam. This is the beam. Here it is hinge support. Here it is roller support. This is the span L. Here the representation of the uniformly varying load is, it is also called as triangular load. It is also called as triangular load. Here this is represented here W per meter. W per meter. That means for each meter length the increment is W per meter. So therefore the load increases at constant rate along the direction of the load. Along the direction of the load. It is the load. It is the load. It is the load whose magnitude varies along the loading length, with a constant rate. That means load increases with a constant increment. It is represented by W per meter length. For each meter length the increase is W load. It is also known as triangular load because the area of this triangle will give you the total load. Area of this triangle will give you the total load. These are some types of loads. Some of the types of loads. Now we will see some definitions. First definition we will see what is the definition of shear force. Shear force. It is represented by EF, SF. Shear force. Some definitions. Shear force. What is shear force? It is defined as the algebraic sum of the vertical forces acting at any section of the beam to the right or left of the section. It is algebraic sum of the forces to the right or left of the section, because we can see this calculation of the shear force in the problems also. Then this definition is clear. Now I am writing the definition. It is defined as the algebraic sum of the vertical forces acting at any section of the beam, to the right or left of the section, to the right or left of the section. This is the definition of the shear force. Then what is the definition of bending moment? It is defined as the algebraic sum of the moments to the right or left of the section. It is defined as the it is defined as the algebraic sum of the algebraic sum of the moments of the forces, the moments of all forces acting at any section of the beam to the right or left of the section, to the right or left of the section, to the right or left of the section, right or left of the section. Next, then this is called bending moment. What is the next is, what is bending moment diagram? What is bending moment diagram? Next definition is bending moment diagram. Bending moment diagram. Bending moment diagram. What is bending moment diagram? The graphical representation of the variation of the bending moments along the length of the beam is known as bending moment diagram. The graphical representation of variation of bending moment along the length of the beam, is known as bending moment diagram. Bending moment diagram, because you come to know this in clear while solving the problem. We are solving bending moment calculation and drawing the bending moment diagrams. Now, then what is shear force diagram? SFD, shear force diagram. Next is shear. It is represented by BMD, bending moment diagram. Shear force diagram, it is called SFD, shear force diagram. What is shear force diagram? The graphical representation of variation of shear force along the length of the beam, is known as shear force diagram. Shear force diagram is known as shear force diagram. Now we will see two types of moments are there. Types of moments. There are two types of moments. One is sagging bending moment, another is hogging bending moment. One is sagging bending moment, another is hogging bending moment. First one we will see the sagging bending moment. Sagging bending moment. Sagging bending sagging means I will write, if the bending moment diagram is sagging, this is the shape of the bending of the beam. This is called positive bending moment. Here moment, here moment. Here you see concave portion is here, the concavity is upward. See, this concavity is upward, convexity is downward. Concavity is upward, convexity is downward, then it is called as sagging bending moment. The tendency of the moment is to bend the beam such a way that concavity upper side and convexity downside of the beam, then such type of the moment is called as sagging bending moment. Or the tendency of moment is to bend the beam, bend the beam in such a way that convexity downwards, and concavity upward, as shown in figure, as shown above, as shown figure above, is called sagging bending moment. Sagging bending moment is called sagging bending moment. Sagging bending moment is taken as positive. Sagging bending moment is taken as positive because downward convexity, here upward concavity, it is concavity, here downward convexity, such type of the bending, and what is the of the beam and the moment causing such bending, it is called sagging bending moment, and it is represented by positive sign. Next one is hogging bending moment. Hogging bending moment. Hogging bending moment. Hogging bending moment. It is hogging means it is like this. It is a hogging nature. This is the beam, bended beam. See here moment I am applying in this direction. Then here this type of the hogging, it is represented with negative sign. Here convexity upward, concavity downward. Such bending moment it is called as hogging bending moment. The tendency of the moment is to bend the beam in such a way that convexity is upward convexity is upward, and concavity is downward. Concavity is downward. Concavity is downward, as shown in the figure. As shown in the figure. Then it is called as hogging bending moment. Then it is called as hogging bending moment. Hogging bending moment. Hogging bending moment is taken as negative. Hogging bending moment is taken as negative. Therefore, the hogging bending moment is negative, sagging bending moment is positive. One more definition we will see. It is the last definition here. One more definition we will see. Point of contraflexure. What is point of contraflexure? Point of contraflexure. Point of contraflexure. What is defined? What is point of contraflexure? A point of contraflexure is a point at which the bending moment is zero. Therefore, the point of contraflexure is a point at which the bending moment is zero. The bending moment is zero. Also at point of contraflexure, bending moment changes. Its sign from hogging to sagging, and vice versa. This is the definition for point of contraflexure.